Hi, my name is John Mathai. I'm a master's student at the University of Illinois under Dr. Hans Stein, and today I'm going to present to you on the energy concentration and amino acid digestibility in corn and corn co-products fed to growing pigs. We'll start off with an outline. We'll start with an introduction, then we'll move into the nutrient composition of the ingredients that we used. We'll follow up with the first experiment that determines the energy concentration of these ingredients, then the second experiment, which deals with amino acid digestibility of these ingredients, and we'll follow with the overall conclusions, and then I'll leave you with the take home message. For this experiment, we used four wet milling byproducts, and those ingredients were corn bran, which we will call bran, high fat corn germ, which we will call germ, liquid corn extractives, which we will refer to as LCE, and then a mixture of corn germ meal and the corn extractives that we'll call CGM-LCE. So the first ingredient was corn bran, and what this really is the pericarp of the corn. It's the most fibrous component of the corn kernel, and it's being investigated as a separate feedstuff or as one that can be blended with other ingredients. The next ingredient is high fat corn germ, and how this corn germ differs from typical dry grind corn germ is that it has a higher fat content. Typical dry grind corn germ has about 16 to 18% fat, while wet milled corn germ, which is what this is, has between 30 to 40% fat. The next ingredient is liquid corn extractives, and this is really composed of the soluble portion of the corn that has been removed in the steeping process. And it's important to investigate because there's very little data available. And the next ingredient is corn germ meal and liquid corn extractives. And corn germ meal is different from corn germ in that it's been de-oiled, so it has a lower oil concentration and higher fiber concentration. And so this ingredient is important because it absorbs large quantities of liquid corn extractives, so it serves as a kind of vector for the ingredient. So why are we looking at these ingredients in particular? As with any industry, in the wet milling industry, we're trying to maximize the economies of that process. And so we want to make the most out of the co-products. As nutritionists, it's our job to determine which co-products are effective to use in swine. And as any nutritionist knows, the greatest cost of raising swine is in feed. And so we want to minimize the cost of formulating the diets. So we'll start off with the nutrient composition of the ingredients on an as-fed basis, and we're going to be reporting the dry matters in percentage. With corn, we have an 87.21% dry matter. The bran was at 89.94%. The germ at 93.59%. The liquid corn extractives at 60.84%. And the corn germ meal plus liquid corn extractives at 90.87%. The GE on an as-fed basis at kilocalories per kilogram was about 4,000 in corn, 4,368 in bran, 5,929 in germ, 2,018 in the liquid corn extractives, and 4,211 in the corn germ meal mixture. Again, on an as-fed basis, we'll talk about crude fat. And what stands out here is the corn germ, and you see that has about 30.6%. And that's as we expected, between 30 and 40% from the wet milling. And then we have corn at 3.2%, bran at 3.1%, liquid corn extractives at just over 2%, and the corn germ meal plus liquid corn extractives at 2.5%. So we'll go into the first experiment and look at the energy concentration of these ingredients. The objective of these experiments was to determine the digestible and metabolizable energy in all four of the corn co-products. So how do we go about doing this? Well, we had 40 growing barrows with an initial body weight of about 33 kilograms in metabolism cages. We used a 5-day adaptation and a 5-day collection using the marker-to-marker method. The design was set up as a randomized complete block design with 5 diets and 8 replications per diet. Our 5 diets were a corn-based basil diet, a corn plus corn bran diet, a corn plus high-fat corn germ diet, a corn plus the liquid corn extractives, and a final diet of corn plus the corn germ meal and the liquid corn extractives. The statistics were analyzed using the mixed procedure of SAS with a fixed effective diet and the random effective block. The treatment means were found using the LS means function, and the means were separated using the p-diff function. The differences among the diets were tested by pairwise comparisons when the effective diets was significant in an alpha of 0.05. So what are the results from this first experiment? Well, the DE, and this is on a dry matter basis, in corn was the highest at 3,986 kilocalories per kilogram. Then the next was in germ at 3,631 kilocalories per kilogram, followed by bran at 3,204 kilocalories per kilogram. Now we're looking at the ME of the ingredients, and we see that the corn has the highest ME at 3,871 kilocalories per kilogram, followed by the bran, germ, liquid corn extractives, and corn germ meal plus liquid corn extractives, all between 3,000 and 3,200 kilocalories per kilogram. And now you may be wondering, if you were looking at the DE and ME, how come the GE of that germ didn't really translate into a DE and ME as high as you might expect? And that's answered here. And if you look at the ATTD of the GE, we see that it's the lowest in the corn germ at 72.67%, and it's highest in the corn. So now let's move into the second experiment, where we're trying to determine the amino acid digestibility of these ingredients. The objectives of these experiments was to determine the SID and AID of crude protein and amino acids in the 4 corn co-products. So we went about this with 6 growing barrows with an initial body weight of 96 kilograms. They were surgically equipped with the T cannula and distal ileum, and they had 7-day periods with 5-day adaptations and 2 days of collection. The experiment was set up as a 6x6 Latin square with 6 treatments. Our first diet was just a corn-based basal diet. Our second was one based on corn bran. Third, on the high-fat corn germ. The fourth was actually a 50% corn and 50% liquid corn extractives diet. And that's because, if you remember, that our liquid corn extractives had about 60% dry matter. And so to make it a little more viscous, we had 50% corn added in. And our next diet, we had corn germ meal plus the liquid corn extractives. And then our sixth diet, so we could determine our standardized amino acid digestibility, we have a nitrogen-free diet. We analyzed the statistics of this experiment using the mixed procedure again of SAS with a fixed effective diet and a random effect of pig and period. Differences among the means were tested by pairwise comparisons when the effective diets was significant at an alpha of 0.05. So what are the results from this experiment? The first thing that stands out, I'm sure, when you look at the slide is the low SID lysine of corn bran. And we don't really have a solid explanation for this. Our best guess is that there were some Maillard reactions during the processing of these ingredients. But the corn had the highest at 73%, followed by our liquid corn extractives and corn germ meal plus liquid corn extractives with about 44 to 53%. We'll follow up with the SID of methionine, which is the highest in corn at 92%, and then no significant difference between the other ingredients at about 73%. For the SID threonine, we see our corn is the highest at 87%, followed by the corn germ meal plus the liquid corn extractives at 66%, and then the corn bran at 48%. We'll follow up with tryptophan. We see it's the highest again in corn at 88%, followed by bran, germ, and the liquid corn extractives at about 75%. So what are the overall conclusions? Well, from our DE and ME experiments, we see that the concentrations of DE and ME were less in the bran, germ, liquid corn extractives, and the corn germ meal plus the liquid corn extractives than they were in corn. But among the corn co-products, we see the concentration of DE was greater in germ than in bran, but there were no difference in the ME among the corn co-products. For the amino acid digestibility, we see the SID of crude protein and all indispensable amino acids was greater in corn than in all of the corn co-products, with the exception of the SID lysine in germ and the SID of tryptophan in corn germ meal plus liquid corn extractives. Among the corn co-products, we see the SID of crude protein, lysine, and valine were greater in germ, the liquid corn extractives, and the corn germ meal plus liquid corn extractives than they were in bran. There was no difference in the remaining amino acids among the corn co-products. So what does this leave us with? Well, compared with corn, the corn co-products used contain less ME and a reduced SID of most amino acids. However, the high-fat corn germ, liquid corn extractives, and the corn germ meal plus the liquid corn extractives are all promising ingredients for the swine diets. Corn bran, however, because of its low SID of lysine and high fiber, may better suit ruminants. And so with that, I would like to acknowledge ADM for their financial support and the supply of the ingredients. And would like to remind you that if you enjoyed this presentation, to visit our website at nutrition.ansci.illinois.edu. Thank you for your attention.